The Misters are testing a real doozy.
Everything's hot, ready to go.
Bullet shot versus bullet dropped. But a malingering magnet is holding up the show.
As soon as it's released, it's just staying there.
But do you think Adam's going to let something like that stand in his way?
Awesome, that works.
Oh no.
So the electromagnetic is gone. It's on the scrap heap. We've got a new little solenoid in there which will whoop, get out of the way and let the bullet drop. All we got to do is try it once, get our timings right, confirm them, and we should be ready to do this test.
So the new simultaneous release system is ready for a test fire.
All right, simultaneous release in 3, 2, 1.
All right, let's see how it did on high speed.
But once again, there's a timing problem.
Solenoid's way too slow.
Yep.
It's not letting go.
The most difficult thing about this whole experiment is getting the fired bullet and the dropped bullet to become airborne at exactly the same time. And we can't tolerate even a few milliseconds of variation in this mix to make the result that we want to see happen. It's hard.
Now there's an understatement. So cue the brainstorm.
We're not even seeing the pin start to move.
It gave us the problem that we currently have, which is that it's late.
Having spent the past 4 hours trying to sort out the solenoid,
Look, let's do this twice.
the boys are now staring failure square in the face.
And all it is about figuring out some way to mechanically push between these two.
Until Jamie snatches victory from the jaws of defeat.
If you have a hinge that you pull in the middle,
Yeah, that's what I
there
mean.
needs to be some sort of a
Oh,
little bitty catch that is on its edge.
Hey.
I could make a clip like that.
He adds a small metal clip to the trigger to delay the gun the minuscule milliseconds needed to match the solenoid.
Everything's hot, let's do it.
And after a few test fires and a bit of fine-tuning, it works.
Bullet leads done. Oh, it's good. It's good. It's 1/3 of a millisecond difference.
Wow.
That's freaking perfect. Let's go do this full scale.
Okay.
Which means rolling up the room 360 feet to stake out a drop zone.
Right about there. That's where they were landing out in the shooting range, so this is where I expect them to land here.
Okay.
Adam lays down a runway of white paper so the high-speed camera will clearly see and measure both bullets at the same time, in the same place, and in the same shot. All we need now in the drop zone is Jamie's drop rig, so the boys can take a shot at physics history.
All right, Jude, you ready to do this for real?
I think we'll hit it on the first shot.
Really?
Oh, yeah.
You never make predictions. That's awesome.
Bullet dropped versus fired. In 3, 2, 1.
But from 360 feet away, the boys can't see exactly where the fired bullet landed.
Let's go see where it hit.
So Adam takes a one-wheeled ride down the room to check out the drop zone.
Wow.
And the results are simply ripping.
Can't get much closer than that. Ugh. I can't wait to see the high speed. So, dude, this bullet carved a streak right under the drop zone. I think this might be the shot we've been looking for.
In real time, it's impossible to tell what happened. Until Adam analyzes the high speed and crunches the numbers.
3677 minus 3915 equals 238 divided by 6. Dude, the difference is 39.6 milliseconds.
Which means it's less than the human eye can make out.
So after days of brain-teasing tests, the Mythbusters can claim a world first for themselves. and a victory for physics.
Let me put 39.6 milliseconds into some perspective for you. When you go to the movies and watch a projected celluloid film on the screen, you know that that film's made up of individual images, right? What you might not have known is that it takes 24 of those per second to make up the film that you're watching. So each one is on screen for exactly 1/24th of a second, but you don't notice that because it's faster than your eye can register. Well, that 1/24th of a second is actually longer than 39.6 milliseconds. That's how close those two bullets were.
2 bullets, 1 dropped, 1 fired. Amazingly, they ended up in the same place at the same time.
Dude, this myth was every bit as much fun to test as I was hoping it would be. And I gotta say, even though the physics textbooks had it right, I love the fact that we did it full size with real unmodified bullets. I bet no one has ever tried that before.
I think you're right. And whether it was ball bearings or bullets dropped or fired, they all hit the ground at the same time.
Yep. Gravity, man. It's not just a good idea, it's the law. Confirmed.
Confirmed.